I'm sorry. We were supposed to be 2 people to do this presentation. Unfortunately, Stefan cannot be there. I guess I will start. And I'm not exactly the expert in Ceylon, but hopefully I'll be able to, walk you through, the idioms we are going to talk about today. What? Oh no, that's the wrong slide. Dynamic aspect-oriented object kernel? No. Oh, this one. So this one is a language which is basically a 2-dimensional topology, and navigation is actually driven by the language itself. But unfortunately, it's actually not Ceylon.
Pascal zal neigen op de slides. Er was er juist een storing met Roos.
Hallo?
Van zijn computer of komt dat van bij ons? Nu
Sorry guys, I cannot do this alone.
Ja.
Stefan? Hello? Hello? So come on, everybody's waiting. I don't know the slides. Please help me. Because, we draw and you lost. That's it. That's life. So come on now. Don't be Come, Harry. He's coming. So. There you go. Please welcome him. See, it wasn't that hard. So Stefan, which contrary to how it looks, is actually the man that will be able to explain Ceylon. So how about you remove that and we put a mic and you get started.
So, why is it always me?
For the head, well, I guess I've got seniority, so you have
You have seniority, all right. So I am the one with the elephant costume, and I look like an idiot. Hi, anyways. So this is going to be a special talk today. I guess you've probably gathered that from how we looked. You'll understand more in a few minutes.
Hopefully.
Hopefully, or it will be lost forever. So, brief introduction about how Ceylon came to be. Ceylon is a new language for the JVM and for the JavaScript VM that came about, originated from Gavin King, who unfortunately couldn't make it today. And one of the goals was to improve upon the frustrations of the Java language, which we love, but we feel that it's something that was written a long time ago. And one of the idea was, what would Java look if we had to make it today? Try to make it as good, but more modern as well.
Yeah, and of course embracing all the good stuff. So.
All the modern stuff. So the first thing to know is that it's a static language, because it provides great tooling support. And let's face it, we all know that dynamic languages suck, really.
Yep, I agree.
That's no question.
Bullshit! Bullshit!
What?
Dynamic languages don't suck, come on! Dynamic languages are the best languages ever, and Groovy really...
Oh, come on.
Come on,
No.
you know that.
No,
What are you guys
You
doing?
should be using Godot, which is the best language for the
And
JVM.
Groovy, come on.
All right, so this is
We're gonna
Julien
figure
Ponche from Golo and Guillaume Laforge from Groovy. Trying to, okay, well, I guess I was a bit unfair. Dynamic languages are actually useful, and there's a room for static typing, for dynamic typing, and obviously dynamic languages have a big part to play, and we respect that, right? We know that dynamic languages are useful and they're used in production and everything, and they're very respectable, right? I mean, it's just a different way of writing languages, right? So don't worry, we've fixed it, and we also, to be fair, static languages are very readable, right, compared to dynamic languages. I mean, take this. This is C code, winner of the obfuscated C context in '96. This actually compiles and runs and everything. It's obvious that static typing is always more readable than dynamic. But okay, dynamic typing is good as well. Thanks.
Thank you.
Good. Oh, great.
So more seriously, what is Ceylon? Why did we study this language, really?
I think we were bored. That's how
Well,
every...
nothing to do, we'll look for a job.
No. So Ceylon is a language that is powerful. We already said that it's a modern iteration of what we would love Java to be. So it has all the goodies that you expect from a language that is being done in, what year are we again?
2013, I guess.
13. Man, time flies. It's something that we want to be readable, because we know that when you write a language, when you write a program, then you're going to write it a number of times, but it's going to be read a lot more times than it's going to be written. So because the next guy is going to come and have to read your code, even yourself.
That's a language for teams. So
Right. It's definitely a language for enterprise teams that have to maintain large code bases, which is what Java is great at, and which is what we aimed for Ceylon as well, to be readable and predictable, have a small set of rules that everybody can learn and understand and remember, and when you look at a program, it's obvious what it does.
Yeah, every time a rule was too complex, or every time there were ambiguity and two potential rules, we made a choice. We sometimes did remove the whole feature because it wouldn't fit the predictability mantra of Ceylon.
So Ceylon is more than just a language. It's not syntactic sugar over Java. It's also a platform. It has its own SDK. It compiles to the JavaScript VM and the Java VM. So it's able to run on your browser, on the server, on Node.js, on the JVM. It supports modularity from the go. So you have a very small language module, and this is the only thing that is integrated in the language. The full SDK is actually modular. You can download it online. And we have great tooling. We have an Eclipse IDE. We have a great command line with plugins. We have a module system called Herd. And we have an IntelliJ plugin in the works as well.
Yeah, so we started tooling from the very start of the language. So we also improved the language to make it very easily toolable. Again, as well, modularity was built almost from the start. So we reworked the whole SDK to be very modular.
Is your mic on?
Sorry?
I can hear myself more than I can hear yourself.
I know. Right.
So we're going to go on a tangent here and show a bit what's behind the scenes of Ceylon and what's done to people working on the team, what it was like working on Ceylon, and in particular what it does to people. I mean, for instance, I had hair.
That's you, right?
That's me 2 years ago. That's when I started working on Ceylon.
You were already unhappy, though.
I wasn't happy, but I had hair. I was a lot happier than now, right? Obviously, it's
Curly hairs, we cannot really get
no,
it from
something happened. Something it does something to people working on it. What it's like working on Ceylon. I think we were really fast, right? I mean, we announced the language 2 years ago, and it took us 2 years to do it, and in many ways, we were actually fast because we were not so many people working on it, but it feels from the outside that we didn't, go very fast. I think from the inside, I think it's clear that we accomplished a lot more things that we set out to accomplish.
Yep.
We had very nice initial reactions when we announced Ceylon, right? We had absolutely no trolls whatsoever. That there was an overwhelming welcome to the language. Everybody cheered.
So we didn't have a website, we didn't have any online presence, but we got slashdotted nevertheless and got very good feedback from the trolls on Slash.
Right. And we had a clear roadmap, right? I mean, obviously, like writing a language, we know exactly where we want to go and how to get there. And then obviously we discovered a few bumps along the way, but mostly, we got there. We did have to make a few adjustments to be taken seriously because it's a well-known fact that if you don't have a beard, then you're not a serious language designer. Hence why my hair migrated to the chin, I guess.
I only had the mustache, but I'm not exactly in the team, so.
Yeah, half in the team. Gavin was the one that had to make the most adjustments, I guess. But that's what it is. I guess we're done for the serious part of the presentation,
Yes.
right?
Let's go crazy now.
Let's go crazy. So I think we have something to talk about now, right?
Yeah.
We have something to announce, but maybe we can get somebody more interesting to announce it, right?
Yeah.
Do you still have your phone? I lost mine.
Well, can I pretend I'm calling him?
Right?
Hey, can you actually show up and demo
He's
your
going
actual
to
language?
answer. Right. So we have somebody special, a special guest tonight that actually could make it last minute and accepted to come and talk and be part of the presentation. The bearded guy, who apparently lost his beard along the way, unfortunately. Welcome, Gavin King.
So yeah, I would like to thank my colleagues, Steph and Emmanuel, who are both very funny. And yeah. So Steph, obviously proposed to DevOps a talk with 99 Ceylon idioms, and then yesterday I found out that in fact he hadn't produced any actual idioms. So on the plane,
he's been very busy lately.
He has had some distractions. On the plane on my way here, I did manage to come up with 8 idioms, which means that my talk is going to be 81 idioms worse than Steph's. But it has the advantage of
we did have 2 Ceylon idiots. It's a start.
And now 3.
And now 3 idiots.
It's improving. We're improving as we go along.
We're growing really
fast. To join the community.
So let's get started with the idioms. Oh, and I think we've forgotten about something, which is that Ceylon 1.0 is now available to download, and it's actually real. So what does that mean? It means that we have a version of the compiler and the IDE and the tooling that is ready to go, that you can use, that we think is not full of bugs. Doesn't mean it has no bugs, of course. Any software has bugs, and that the basic language is stable. That for the rest of the 1.0 time frame, we plan to maintain source level compatibility. We do plan to break binary compatibility in Ceylon 1.1. That's not something we do lightly. We do it with great misgivings, but it will happen. And then, our normal policy will to not break binary compatibility, except in major version numbers. Obviously, the Ceylon platform, the Ceylon SDK, is still evolving and still being developed, but the language itself is now stable. So let's switch gears, and I know you guys came because you want to hear something actually about the language itself. This chair isn't a really inconvenient spot. So I'm going to, this is not going to be a deep dive of any sort. This is going to be a little, revision of some of the kind of just little idioms. My interpretation of idiom is something small, a little trick where you do something a little bit different in this language than in some other language. So the first idiom we're going to look at is the notion of a function which has multiple outcomes. So for example, imagine I have a function find by name, which might return a person, it might return an organization, and these two types don't have any kind of common supertype, or the function might not find anything. So in Java, I think it's pretty common to handle this kind of case with a function, taking the assumption of no common supertype, it would kind of return object or something equally kind of vague. I think returning null from APIs tends to be something that's a little frowned upon, because the semantics of the null, or the fact of what that null captured, is not captured within the within the static signature. So it's quite common to throw not found exceptions, for example, array index exceptions, things like that in Java. Then when I call this function, what do? Well, I need to kind of look at what I've got with instance of, and then I need to, typecast the result to something, catch the exception. And, this code's a little bit broken, because, there's this kind of undefined case of, well, what if find my name doesn't return an org or a person? Probably I need to add some kind of assertion or something in there. So in Ceylon, we handle this case, as with many things, as we'll start to see, we handle this case with, we can at least handle it with a union type. So I can have a function which returns, different kinds of things that don't share a common supertype, for example, organ, person. I can even have it return a value that indicates some kind of failure, in this case, not found, and that could carry some information. Then I can handle these various results using a switch. And this switch is exhaustive, and the compiler will analyze and see that you've handled all the possible outcomes of the function, right, which is a little bit different to what we had in the previous code example. I can even, I can say org or person. I can write in a union type as one of the cases, and so I can have cases which handle multiple outcomes at the same time. Inside those blocks, the little ... which I've stuck in because I got too lazy to write anything else. It was more I couldn't fit it on the side. The type of result has changed, has been narrowed. So in Ceylon, the operation of testing the type of something also narrows its type. So it's not test type and then narrow, it's one operation. This is something called flow-dependent typing. A special case of this idea of functions which return multiple values is the idea of a function returning null. That might see multiple outcomes is the case of a function that returns null. It might seem a little bit strange until you realize that in Ceylon there's no notion of a primitive null value, right? In most languages, null is an instance of the bottom type. Okay, it's an instance of every type, if you like to see it, and so it's kind of this lying thing. In Ceylon, there's no primitive null, at least at the level of the language and the type system. And so null is an ordinary object. It's an instance of a class called null. And Ceylon has some syntactic sugar. Ceylon is a language with a very simple type system and a lot of syntactic sugar layered over that. Okay, if you have a simple type system without a whole lot of kind of tacked on higher level constructs, you need to, and you're going to build everything up out of the simple basic type system, then you're going to need to add some syntax sugar to present that to people in a more easy to use way. So for example, one of the things we do is if you have a union type of form item or null, it's a common thing. I'm saying the get method of map might return an item or it might not return anything. Then we have a little bit of syntax sugar. You can write that item question mark. So if I create a hash map which maps some strings to some time zones, and then I use the square brackets operator to pull out an item of the map by passing a string, then obviously that could return an item or it could return null. This square bracket operator, I should say, is just another bit of syntax sugar. It's just a syntax sugar for the get method of interface called correspondence. That is a super type of map. And then I have the else operator, which will let me provide a default value. Again, if I would not have provided that else block, that else operator, and I just written time zone tz equals map of name, the compiler would have rejected the code because I wouldn't have handled one of the outcomes, namely the possibility of null. This means that in Ceylon, there are no null pointer exceptions. In pure Ceylon code that doesn't interoperate with native JavaScript or native Java code, there is simply no possibility for a typing exception like that, a null pointer exception at runtime. Okay, so what people often ask is, what if I know, what if I know that this operation, for example, get here that we were just talking about, can't return null because of some other test, some other constraint upon the key that I previously made. For example, here, I already checked that name was in the map, so I know that if I call get name, I'm not going to get a null back. Well, one way we can do that is using an assertion. So in Ceylon, an assertion, unlike in any other language I know of, can actually be used to narrow the type of something. Okay? So an assertion of this form, assert exists, is like an assertion that says assert is an object. It's testing that this is a subtype of object. And if it's not, then an assertion of failure will occur. If it is, then from then on I can treat TZ as if it were an instance of time zone and not of time zone question mark, or not of time zone or null. Obviously, there's a shorter way to write that code, and this is actually what often happens in Ceylon, is that we wind up turning things around. First, we try to retrieve the value, and then we test it, rather than checking if it exists in the map first, which is what you would do typically when working with arrays in other languages. So we immediately pull it out with the if. The if also supports these kind of flow-dependent typing, these typing conditions. And so we would typically write that code that way, and that's completely type safe. So we've talked about outcomes, handling multiple outcomes. What about inputs of inhomogeneous form? So this is what people often ask about. They talk about overloading. I'm not sure if overloading is necessarily the right way to think about what the problem is, but that's fine. You know, so an example in Java, if I have a type float and a type integer which don't have any particularly good supertype that abstracts over them, and I want to have a function that applies to either of those types. Well, typically what I would do is I would use overloading, and I would write what are essentially two functions that just happen to have the same name. What's the difference? Well, what that means is that I can't abstract over them. Okay, I can't refer to the function square root. There's two function square root, and they can't be abstracted over. They're actually two different, essentially unrelated operations. So in Ceylon, bad news. There's no overloading, and this is a restriction that is not always totally easy, totally without cost. It comes at a cost. But we can achieve some of the same effect by using a combination of language features. But for what I'm going to focus on here is the idiom of using a union type instead of overloading. So we can define a single square root function that takes either a float or an integer and switches on the type of it. Now, this is less flexible than fully fledged overloading, clearly. On the other hand, it also has some advantages. First of all, it's a single operation, so if I have something that all I know is that it's either a float or an integer, I can pass it to that function. All right, which is what I'm doing in the definition of fourth root. I have two calls to square root, one of which is passing a float or integer, and the other one of which is just passing a float. More importantly, and the reason the restriction against overloading exists, is that I can take a function reference to the function without needing to kind of specify explicitly what its argument types are or anything. I don't think that overloading works well in a language with higher order functions, with function references. So for the record, what you're looking at in this final line of code is a function type. That's how we write a function type in Ceylon. It says the return is a function with return type float, and which takes a single parameter of type float or integer. This in itself is just a syntax sugar. Okay, the actual underneath function types are modeled using an interface called callable and a class called tuple, which I'm not going to reach right at this moment, but once again, even function types are defined within the language. My fourth idiom is multiple return values. We've talked about multiple outcomes, i.e. could have either this outcome or this outcome, but what about cases where I have a function that wants to return two values at a time? If I were writing Java, I would, write a class to encapsulate those two values. And look, I don't think that this is a bad thing. I have long argued that it's very, that almost all of the time, it's probably better to do this kind of thing. However, it turns out I'm kind of wrong about that. The usefulness of having a function which returns multiple values without needing to define a class that encapsulates those values, it can be seen from the fact that if I told you guys that, oh, you only need functions with one parameter, you would laugh at me. So yes, you need functions with multiple parameters, and so and for much the same reason, you also need functions with multiple return values. So the way we handle this is with tuple types. So there's a class called tuple in Ceylon, in the Ceylon language module, and there's syntax sugar, which lets us express types involving the class tuple in square brackets. And there's a syntax, also a square bracket syntax for instantiating tuples, which is again a syntax sugar for an instantiation of this class tuple. And so I can define a function which returns two objects without needing to have a class that encompasses them. Now the caller of the function can extract those values using this same square brackets lookup operator. So lookup operator is defined on a very abstract interface called correspondence. Map is a kind of a correspondence. A list is a kind of correspondence, and a tuple is a kind of list, right? So the square bracket lookup operator also applies to tuples. Now the compiler, there's some syntax sugar involved here, though it's actually not completely syntax sugary. When I pass a literal 0 or a literal 1 as the key of the lookup operator, Ceylon can statically check what kind of thing was there at that element, right? Because it knows it has a tuple of name and address, so name and address of 0 is a name. Name and address of 1 is an address. It knows that. What about if I pass in an index which has nothing, or an unknown, or an integer, a variable index? Well, in the case where I pass in 3 or -1 or something like that, I'll get out the type null. Okay, this is saying explicitly, and this is something the compiler can reason and deduce implicitly, that there is no other possible return, there's no other possible value at that element than null, than the object null. What about if it's index, and I don't know if it's -1, 1, 2, 3, 4, or whatever? Well, then what I know about it is that it's at least a name, address, or null. Okay? How does that work? Well, a tuple of a name and an address is a list of name or address, actually, and the index operator for a list has that type. What about if I have some function or class? In this case, it's a class. A class in Ceylon is just basically a special kind of function. In fact, it's fairly deep in our understanding of what a class is that it's a function. So I have a class called snailmail, which takes a name and an address. And I have this function we just wrote called getNameAndAddress, which returns a tuple. So I want to compose the two of them together, and I want to create a snail mail from the thing that getNameAndAddress just returned. And now what I've got here is a tuple type, and what I've got here is two parameters. So obviously I could write snail mail of 0, snail mail of 1. Or I can do like Groovy, and I can spread it. Okay, so have people seen this kind of syntax in Groovy or some other language, dynamic languages, where you can spread a tuple, or a list normally, whatever the construct is called, across the parameters of a function? I think you can do a similar thing in JavaScript, but maybe I'm talking out my... Now, in a dynamic language, what that means is, well, like anything in a dynamic language, well, we hope we got the right length of the list and all that. In Ceylon, that's statically checked, right? I can't spread any tuple across the parameters of snail mail. I can only spread a tuple of name address. And this is a very deep relationship in how the language models the notion of function types. Do you recall that I just said a second ago, and you probably didn't notice, I said that a function type is expressed in terms of the interface callable, a return type, and a tuple type that embodies the parameter types of the function. This comes out of mathematics. In mathematics, when I define the notion of a function constructively based upon sets, what's a function? A function is a set of ordered pairs. You probably remember that from high school mathematics, right? What's the definition of a function, right? The word function. What does it mean? It's a set of ordered pairs. What's the definition of a function with multiple parameters? It's a set of ordered pairs where the second element of each ordered pair is itself a tuple, right? So this is the definition that comes from mathematics. Other statically typed languages, for some reason, don't make that connection, right, to the basic mathematical model of, of how to set these things up. And this turns out to be important because it means that if a function type is just an instantiation of the interface callable, right, rather than, for example, in Java, where, please don't read this as a criticism of Java lambdas. I think it's great what they've done. But in Java lambdas, a type of a function is comparable, or some, they have lots of kind of predefined interfaces that they think will, provide most of the kind of function signatures which you will need, and you can define your own. But I can't abstract over them. Similarly, in a language like Scala, I have F, F1, F2, F3, F4, up to F22. Again, I can't abstract over them. In Ceylon, I can abstract over function types because there's just one type of function callable. So I can write a function like function composition using compose that will accept a function. Oh, that isn't what I wanted. Ooh, okay, that's too small. Forget it. So I can write. The point is that I can write higher order functions which extract over functions of unknown arity. Arity being the length of its parameter list, right? So let's look at a practical use case of this. Somebody posted in the mailing list, this very problem. What if I want to compose, not call snail mail with a tuple, which is what we're doing in this example with the spread operator, but what if I want to compose the function snail mail with the function get name and address and produce a new function without actually calling it, without actually invoking it? Well, I have my compose function. And then I also have another little very, very useful function that's super useful that you can use to define all kinds of interesting things called unflatten. In fact, compose itself is defined in terms of unflatten. Or flatten, I forget. Yeah, it uses both of them. So what unflatten does is it takes a function with multiple parameters and turns it into a function that accepts a single tuple type. Accepts a single tuple, right? So in this case, I'm taking snail mail, which accepts a name and an address, and I'm turning it, by unflattening it, I'm turning it into a function which accepts a tuple name address, which is what get name and address produces. So now I can compose them together using the compose function, and I get something of type, so get name and address accepts a person. So what I get out of this is something with the return type of snail mail, which is snail mail itself. It's a constructor. It's a class. And the parameter type of get name and address, which is person. And now I can, pass it a person and get out a snail mail. We're going to come back to yet another idiom that involves union types. Something that, I hate and despise the definition of the interface set in Java because it doesn't have the most basic constructs that you use when working with sets, which is union intersection. So I sat down on the plane here and I tried to write down the definition of the method union of set in Java. I knew I was going to fail, but I had to remind myself in precisely what way it fails. And you can almost do it, right? You can't quite do it because Java doesn't have lower bounded type parameters, right? Scala does, and so you could actually write this function, this method in Scala. So what this is saying is that I have an unknown type u which must be a supertype of the element type of the set itself, T, and must also be a supertype of the element type of the second set that's being passed as an argument. And then, you know, so if I were able to write this in Java, then I would be able to, you know, given a set of foo and a set of bar, I would be able to get a set of foos and bars, and I could kind of essentially arbitrarily pick a common supertype of foo and bar as the element type of this return set. So in this case, object, right? Kind of lame. First, it's lame that I can't actually write it down. Second, it's lame because object. In Ceylon, because we have union types, the signature of this function becomes trivially easy to write down. Unions of values correspond to unions of types, right? If I have a union of a set of T's with a set of U's, then I have a set of T or U. Right? So the signature of that function is actually enormously intuitive. And then if I have a set of foo and a set of bar, I don't even have to explicitly write down in Ceylon, because Ceylon has principal typing. I don't need to write down any explicit types. I could have just written value there, right? What automatically pops out is a set of foo or bar. This bar operator on this side is not the union type constructor bar that we see in type expressions. It's a syntax sugar. It's an operator bar for union of sets. Okay, that's just another syntax sugar. It just means calling the function union of set. So what pops out automatically is a set of exactly the right kind. Then, because set is, I actually screwed up. I should have declared set to be covariant, because then it would also be a set of object. What I'm demonstrating here is a property of the language called how principal typing and covariance work together, so that you don't get this ambiguity that you have in Java, where back here, where U is kind of this unknown type, and I could pick several different values for it, and the compiler, and it can't really be inferred by the compiler. In Ceylon, it can be inferred because every expression has a single best, most specific type, without me needing to give extra hints by writing a type on the left-hand side. Yes.
I think I will interrupt you.
Okay.
Move to the demo. No?
I can do this in one. I can do the rest in 1 minute. Intersections of values. Now let's try to write down the intersection in Java, and I'll leave that as an exercise for you guys, because I tried several things, and everything I tried, I ran into 2 or 3 different ways in which Java wouldn't let me write it. Okay. So this function intersection of set in Ceylon, it's exactly the same thing. It's just intersection, right? Easy as you're seeing the same thing with intersection and set of union. And it turns out that this is actually an extremely useful and common idiom. Consider, for example, the coalesce function, all right, which is a function that takes an iterable. This curly brace syntax with a star is, again, another syntax sugar just for the interface iterable and so on. Turns out to be extremely nice. It might be a little bit threatening now, but you'll get used to it, and it's actually a nice syntax. This takes an iterable of elements and produces an iterable with the nulls eliminated. How can I express that? I can express it with an intersection type. Object is not a subtype of null, so null is not a subtype of object. They're disjoint types. So element and object is the iterable with the nulls eliminated. And you can see I can implement it easily, very easily, using a comprehension with an if exists. Again, we're seeing flow-dependent typing in the middle of a comprehension. So exists, if exists, E is narrowing the type of E from element to element and object. Right? More flow-dependent typing, this time in a comprehension. And what happens is that exactly the right type pops out automatically. And now I'll hand back to you guys.
About this.
You can talk about it if you want.
You talk too much, Gavin.
Yes, I know.
All right. Okay, so I'll do the last idiom for you.
I like how you walk on stage with your tail in a very...
Oh, I still have my tail, right? So this is an example of how you interact with the Metamodel, which is the reflection library we have in Ceylon. Here what you're seeing is a function Metamodel where we have a list of declarations, and you can see with the backtick package or JBoss example test, it's a package literal. Like in Java you have class literals. In Ceylon you have class literals, you have value literals, you have module and package literals. So we can iterate, we can get all the members annotated test in this package, and then when we iterate them, if they have no parameters, then we are going to apply the class with type arguments, so in case they have type arguments, and then we can instantiate the class directly. So you can see here that model would be the equivalent of class in Java. We actually separated the class declarations and the class instances where the type arguments are applied, because the type arguments are reified in Ceylon. And you can see that we can directly instantiate the class object, and it's a function, and it will return a new instance. So this is something, iterating over packages and modules is something that is typically hard to do in Java, and you need to look at the class path and everything, and in Ceylon it's just part of the Metamodel. Right, so I'm going to do a quick demo to, you know, we've shown you dead code that doesn't move, and now I'm going to show you code that actually moves. The demo I have today is we are going to have a client written in Ceylon, compiled to JavaScript, that runs on the browser, that is going to talk to a server written in Ceylon, compiled on the Java VM. So we have here a module called server. Is this big enough, or should I make it bigger? Yeah, good. So we have a module called server. It imports a number of modules, so this is typically what you would put in module descriptor outside of the language if you were writing Java, unless you wait for Jigsaw, which apparently is not going to have that for you, just for the JDK, which is really sad. But anyways, we import here a number of Ceylon modules from the Ceylon SDK. We import Java base, which is actually, we have a modularized version of the JDK, so we took the same map of names to packages that they defined in Jigsaw, and the biggest one is Java base, which contains practically all of the JDK. We have a Postgres module as well we depend on. And then I'm going to look at the implementation. I have here an SQL get SQL function, which instantiates a new data source for accessing Postgres. So this is, you can see interrupt with Java code is rather straightforward. I have here a read SQL function, which is going to iterate over all the rows of that select thing. And it's going to assert that the name, version, and downloads exist. So here I'm hitting the database of modules from Ceylon Herd that I have running locally, or a module repo. And I'm selecting those things, and I'm invoking a callback, which I got as a parameter. Callback takes a name, function, name, version, and downloads. And this is my main function, so it's just a top-level function that you can write in Ceylon. It has no parameter, so you can invoke it directly. I get an SQL connection, and then I start a new server, which is part of the Ceylon.net SDK. So I instantiate a new server, and I will open a new WebSocket. And whenever it starts with /WebSocket, I'm going to have a callback on open. I pass a function directly to the constructor of WebSocket endpoint. You can see here I'm passing parameters by name. So this thing says I'm invoking the WebSocket endpoint constructor, and I'm passing the path parameter is going to be this. The onOpen parameter is going to be this function, which returns void and takes a WebSocket channel. And I'm going to read SQL, which is the function I showed you just above here. And I'm going to pass as a callback this function. I'm going to get the name, version, and download. I'm going to create a JSON object out of it using the SDK for JSON. I'm going to print something, and then I'm going to send the pretty version of the JavaScript over WebSocket. And I could do something asynchronous, but here I'm lazy. I'm just going to do sleep. So I'm going to sleep and then let the client deal with this. So let's start the server before I forget. All right, and then I'm going to show you the client now. So the client is two things. The client is some HTML, so where I import jQuery, require.js, because the module system on JavaScript is mapped to require.js, which is, I think, one of the most common module system for JavaScript. We configure it by telling it where the list of modules are located. So here, over there. Then I'm going to load my client module, Ceylon module, when jQuery is ready. I'm going to require that module. And I'm going to register a callback on a button, and when I click it, I'm going to call my client. Okay? So let me show you the client. The module descriptor of the client is simple. I'm only importing the JSON part of the SDK, so that you can see that the SDK works on both backends. And I have here my run function. So this is how we do interrupt with JavaScript. We can define dynamic blocks where you can actually access things that are not typed. For instance, the WebSocket constructor is something that is defined by the JavaScript library. So we open a WebSocket to our server. We invoke jQuery, again, something that is dynamic. And then we register a listener on the socket, and when we get a message, we get an event, and I'm going to parse the JSON from the data, and I'm going to again check that we do have the name, version, and download. And then I'm going to construct some HTML. I could actually replace this with the HTML module we have now in the SDK, and I'm going to append it online. So I'm going to read the WebSocket. Whenever I get data, I parse it to JSON, I check that it's good, and then I create an element and I show it on screen. So this is what it looks like, if I can find my browser back. So I have this button. If you remember, I registered a callback, which is going to start reading from the WebSocket. I guess I need to reload it. And this is where everything breaks. Typical demo effect. Something went wrong. I have no network, I have no jQuery. Okay, this is going to be very funny. This is really lame that I didn't put jQuery locally. So we'll see if this actually works or not. Well, okay, it looks like it's not going to work. Okay, this is lame. I'm really sorry about this. I don't have jQuery, so I can't register the callback. No. So what you should see happen is actually every element popping up one after the other. I get no network, so I can't show you that. I don't think there's another cable for this. All right. Sorry about this. So we go back to here, and okay, hold on, I just got network. There you go. Okay, good. I have network. Right. Phew. So you can see it's reading from the WebSocket. It gets notified every time it has data that is pushed to it from the server. This is asynchronous, at least on the client. We could do it on the server as well. Gavin is trying to talk.
The point is here that we have Ceylon running on both client and server, one on a JavaScript VM and one on a Java VM.
Something that is dynamic, and then we register a listener on the socket, and when we get a message, we get an event, and I'm going to parse the JSON from the data, and I'm going to again check that we do have the name, version, and download. And then I'm going to construct some HTML. I could actually replace this with the HTML module we have now in the SDK, and I'm going to append it online. So I'm going to read the WebSocket. Whenever I get data, I parse it to JSON, I check that it's good, and then I create an element and I show it on screen. So this is what it looks like. If I can find my browser back. So I have this button. If you remember, I registered a callback, which is going to start reading from the WebSocket. I guess I need to reload it. And this is where everything breaks. typical demo effect. Something went wrong. I have no network, I have no jQuery. Okay, this is going to be very funny. This is really lame that I didn't plug, didn't put jQuery locally. So we'll see if this actually works or not. Well, okay, it looks like it's not going to work. Okay, this is lame. I'm really sorry about this. I don't have jQuery, so I can't register the callback. No. So what you should see happen is actually every element popping up one after the other. I get no network, so I can't show you that. I don't think there's another cable for this. All right. Sorry about this. So we go back to here, and okay, hold on, I just got network. There you go. Okay, good. I have network. Right. Phew. So you can see it's reading from the WebSocket. It gets notified every time it has data that is pushed to it from the server. This is asynchronous, at least on the client. We could do it on the server as well. Gavin is trying to talk.
The point is here that we have Ceylon running on both client and server. One on a JavaScript VM and one on a Java VM.
Right, and we have interop with both JavaScript untyped and Java typed. So what happens next now that we have version 1 released? Well, Gavin mentioned that we're going to break binary compatibility in 1.1, and the reason is that we're going to focus a lot on performance and runtime performance, not only of the compiler itself to make it a lot faster, but also on the runtime, how your program runs, and the memory footprint. And so we're going to that's why we're going to break binary compatibility. We have to make a few cuts in how we compile things to the JVM. And that's something that's going to happen within a couple months. And Ceylon 1.2 will be the next version with new language features, which we're going to start. It's definitely not something you're going to wait 2 years for. So this is something you can expect in 2014. But something we rarely do when we do this, it's present the team. You know, we show up on stage and you guys have the impression that we did everything, or that we didn't do anything and we're lying, and that's another possibility. But you could assume that we did everything, and that's not true, because we have people working really hard on Ceylon. You can see they're working really hard on the module system, working really hard on practically everything sysadmin related and injecting system exit in our code base. Working really hard on the JavaScript backend, single-handedly, practically. Working really hard on the JVM backend and the configuration system. Working really hard for Surly on the IDE and generally in making the IDE work with the compiler. If you look closely, there's a guy in the middle with a Ceylon t-shirt trying to tackle the JVM backend and the command line system, where we have a really nice command line system with plugins like you do in Git. Working really hard on fixing everything that we break, practically across most of it, right? The backend, the Ceylon doc, the IDE, herd, whatever. I'm working really hard on much the same thing, you know, just fixing things all over the place. And he works really hard on what it is he works on now. The type checking, the spec, the language, and the IDE as well. And the community, of course, because we have lots of people contributing to Ceylon, whether the tools, the compiler, the IDE. We have people working on the build system now. We have people working on the SDK. We have people working on the IntelliJ ID plugin as well. Lots of things very interesting happening now. And this is where we talk about, you know, productization and how we make you pay to use Ceylon. So we have a few ideas of how we're going to allow you to run the program.
This will be a freemium package.
Yeah, it's a freemium package, exactly, right? So you get 15 lambdas for free. You can nest up to 3 for loops, but not one more. Then we can probably sell you extensions for extra for loops. We have the lead edition with 666 lambda per modules, but we have a limitation of number of classes. Then we have a pay-as-you-use function calls. Every time you use a function call, we bill you like a cent or something, and as many type parameters as you want. So we have a very focused idea of how to milk everyone with Ceylon. Now this is open source. Everything is open source. Even the great module repo that I didn't show you, everything is available for free online and open source and free software. And you have some more information on how to find us. And now I guess we have time for questions. And if you do ask questions...
No, we have so many T-shirts that I guess we probably can cover almost everybody in the room. So it's a pretty nice T-shirt. That's the one Gavin was having. So come to us after the talk and go get your T-shirts. And we'll open up for questions. We got 8 minutes, so plenty of time. Any question?
Question over there.
So the question is, do we target JDK 7 on what will happen when JDK 8 comes out?
So we do target JDK 7 at the moment, and when nice throw, and you're really
These are numbers.
You can see he codes more than sports.
Okay, I'm not even going to try to throw anything after that comment.
So yeah, JDK 8 is in beta now, and we are definitely going to work in 1.1 on making it work with JDK 8. So yes, we will definitely
that might
support
involve even taking advantage of some of the newer features at the VM level, like some of the method. Help me. Invoke dynamic method.
Invoke dynamic or
whatever
invoke
it's
dynamic
called
is not new, but lambda or default methods in the interfaces.
That too.
If we can. But yes, we will definitely support it.
Question? Yes?
Interoperability with languages that are not Java.
Question is, so you interrupt with Java and I guess JavaScript,
So-
but what about interoperability?
So you've seen today interrupt with JavaScript. Obviously, those are the two languages which we have today. The same mechanism we use for JavaScript interoperability in the JavaScript VM, we really hope to be able to use for interoperability with languages like JRuby and Groovy
With
on the
dynamic
JVM,
languages.
okay, which is pretty. Scala, we haven't looked at. Interrupt with something like Scala is interrupt with a language like Java or Scala is a much harder prospect because you have to provide some kind of mapping between the generic type systems of the language. At some level, we will be able to interoperate with Scala because at some level, it's just some Java classes, right? But obviously, what the Scala compiler produces and what you see in the Scala code is so far apart that just interoperating with Scala classes at the level of treating them as if they were Java classes is not going to be good for anything.
You would see artifacts of the compilation of Scala to class files. But interrupt with typed languages on the JVM is going to be, usually special cases for each of those languages.
That's hard.
But you get the same problem in every static language on the JVM. Interrupt between static languages on the JVM is something that I really think that is going to be the next challenge on the JVM, because you see libraries popping up all over the place for a specific language, and if you want to use a great library written for Scala in Ceylon and another great library written in Erlang or whatever from Ceylon, then you're going to have to deal with interrupt, and all of these languages have a different idea of what is a
and it's a
function.
Combinatorial.
It's so I think it's going to be a challenge, but not just for Ceylon, for every language on the JVM.
As soon as they have generic types, function types, and mix-in inheritance, which all of them have now, it's a bloodbath.
Julian?
So how do you guys deal with null when it comes from a third-party API like an API?
Right. So if it's Java, we actually
repeat the question.
Oh, sorry. What happens when I call a Java API through the interop layer and it returns a null? So at that point, we actually relax some of the type checking rules of the language. We say, look, when it's Java, we simply don't have the knowledge of whether it's a null or whether it can possibly return null or not, so we're going to trust you. If you call a Java function of type string, a Java method of type string, and you declare in your Ceylon code string equals, then we're going to trust you. What will happen is that if at runtime it returns a null, we type check it. We check it for null. We do a null check on the caller side, and we will throw a
you get
assertion.
an exception. You get an exception at the border when the value passes from Java to Ceylon.
Passes between the two worlds.
Right. And if you declare it as a string question mark, then we don't insert a check because then you handle it yourself.
So there are some places, there are some places in the language, and exactly the same is true when we interrupt with JavaScript between the dynamic block and there are some places in the language where there's a well-defined boundary between type safe and not type safe or less type safe, and at that point we insert checks to ensure that we corral the things which are untype safe within a certain part of the system.
Maybe one last question. Yes. So the question is, does Ceylon generate bytecodes or Java code on the Java bytecode?
So I'm looking at Seth to answer because it's his field. How it actually works is that the Ceylon compiler is
I didn't hear the question.
Almost like a front end for Java C. What happens? We parse the Ceylon code, we produce an AST, we type check our AST, then all Steph's work and Taco's work and Tom's work transforms that Ceylon AST to a Java C AST, and then we pass that off to Java C to generate the bytecode.
But the Java C AST is a bit more than Java, so we don't actually compile into Java code.
No, it's not the same as compile. It's not the same as if we would be generating Java source code or something, right? Because there are a few more constructs available within the Java C AST than there are available within the Java language. Let expressions and stuff like that.
Right.
Or maybe one last question, the real one. Yes?
What's the current state of the Ceylon framework ecosystem? Is there a Ceylon web framework number one?
So what about the ecosystem of frameworks for Ceylon?
So we have a number of things started. Like I mentioned, we have the SDK. We have a build system that is starting by people in the community. And we have people that have produced recently the HTML module of the SDK. So we have HTML, we have JSON, we have web client, HTTP clients, HTTP server. We have practically everything. We have SQL. We have practically everything you need to actually start building frameworks now. So I think, and Julien Viette actually started building a framework called Just Saying. And we have, with reflection, that he was missing the Metamodel. Everything is in now, so I guess that's going to happen really soon.
We've been focused upon that underlying bits that you can use to make a web framework, so the HTML module, stuff like that. And now it's time to for people to actually step up and make the actual web frameworks.
Right. We have all the pieces now. It's just they need assembling.
Yeah,
so
but people are already working on it.
So thanks everyone. Go to ceylon-lang.org and come get your t-shirt.
Thank you very much for taking your time to.